Hi everyone, and welcome to our lesson today titled Solving Absolute Value Inequalities. So if you watched the last lesson, we did something very similar, except that all of our absolute values were equations. So we had equal to signs here. Today we're going to talk about what happens when you switch that to like a greater than or a less than, or greater than or equal to, or less than or equal to. So the first thing I want to notice here, I'm going to get right into the first example and we'll kind of like talk our way through it. So we have 3 times the absolute value of x is greater than 15. So we're trying to figure out what numbers can replace this x and make this a true statement. So one of the things we learned in the last lessons, or the last lesson, is that it's difficult to analyze absolute value equations or inequalities unless the absolute value is alone. So the first thing I want to do is, if I can, algebraically, I want to get everything over to the right side here that's not inside the bars. Like, for example, this 3. So how can I get this 3 on over to the other side and get rid of it over here? And I'm hoping that you're thinking I could divide both sides by 3, because this 3 is right now being multiplied to the absolute value. So let's divide both sides by 3 to start. And that's going to give us, these will cancel, the absolute value of x is greater than 5. Now that we have the absolute value alone, we can really think about this and what it means. So we know that absolute value takes the stuff, if you will, the contents inside, and really wants us to position this more than 5 units away from 0 on the number line. So you're thinking, what numbers are more than 5 units away from 0 on the number line? Well, there's lots of them. You know, if you think of a number line and you put 0 on it, there's lots of numbers up here that are more than 5 units away. For example, all these numbers over top of 5 are greater than 5 away from 0. And likewise, if you think of the negative aspect of things, all the numbers down here are more than 5 away. So here's the deal. The quick and easy way to think about this is, when you have the absolute value alone and your inequality symbol is greater than, and then you have some number here, you're always going to be over top of the positive or underneath the negative. Further away, further away. 5 or more away from 0, 5 or more away from 0 in the other direction. So what ends up happening is, to state your solution then, it always kind of works the same whenever your symbol is greater. So it's always going to be that the contents of the absolute value, which we'll call x, have to be beneath the negative version of this number. So beneath the negative 5, that's one place they could be. Or the contents of the absolute value could be up above, greater than, the positive version of the number. Because there's always going to be there's always going to be 2 statements. One's going to deal with the negative, one's going to deal with the positive. And that's because you have 2 numbers that are exactly 5 away from 0. So if you want numbers that are more than 5 away from 0, you have to deal with the 5 and the negative 5. More than the 5, but less than the negative 5. Greater than the 5, but less than the negative 5. So less than the negative, but greater than the positive. And we put or in between because you see how they go in opposite directions? You can't be 2 places at once. Your x values either have to be over here or they have to be over here. It's one or the other, and both are fine. So that's the solution. That's how easy that is. So hopefully that makes sense. Now in the next example, I'm going to turn this symbol around and see what happens when we do a less than. So let's take a look at number 2. So this says the absolute value of a plus 6 is less than 14. So first I'm looking to see if I have anything outside of the bars here on this left side, and I don't. I have the +6, but that's on the inside, so that's part of, the contents of the absolute value. So what I'm saying is these contents are less than 14 away from 0. Less than 14 away from 0. Now, can you kind of see the barrier there? So like here's the number line, right? Here's 0. These contents cannot exceed 14 away from 0. So like I could go to 14, but no further. No further. And I could go this way to -14, but no further. I'm sort of like sandwiched between the negative version of this number and the positive version. I want my distance from 0 to be less than 14 away. Now, this is exactly opposite of this up here. This went further away, right? This is the opposite. This is stuck between two numbers. So what I like to do, the easiest way to solve an absolute value inequality with a less than symbol is to literally sandwich the contents, a plus 6, between -14 and +14. Now you've got to watch your symbols here. So the contents have to be less than 14. Certainly not greater, right? Less than. So less than 14, but at the same time, greater than -14. We want to go this way with the -14. Now, the way this is gets a little tricky. So let's think of this. So if my contents, a plus 6, have to be greater than -14, that's the way we would write it if it was just solo. Now look at how it is down here. See how we flip it around 180? The a plus 6 is on the right and the -14 is on the left. So what would happen is if we turn this around and put the -14 here, this symbol would have to turn and the a plus 6 would be here. So this is what it would look like if I do it solo. So now if we click and drag this down here, my symbol will face this way. Okay? So -14 is less than a plus 6, and a plus 6 is less than 14. In other words, we are sandwiched between them. Now, we have solved compound inequalities like this, so we want to get a alone. So you just think to yourself, if this wasn't here and the problem just read a plus 6 is less than 14, how would you solve for a? Hopefully you would think you're minusing 6 from both sides, so you're going to minus 6 here. You're going to minus 6 here, and you're going to minus 6 over here. And we'll finish this off. So -14 minus 6 is -20, is less than, these cancel, so we just have a, which is less than 14 minus 6 is 8. So the values of a that I can put right here to make this whole shebang a true statement, those a values must be less than 8, okay? They must be less than 8 and greater than -20. So, because again, if we switch that around and write it as a and some symbol -20, then that turns around. So we're bigger than -20, but less than 8, which means I'm between -20 and 8. So if you pick anything, let's pick something between -20 and 8. Think of a number between -20 and 8. Maybe you think, 0. Zero's in there. So float a 0 up here. If you put a 0 here, 0 plus 6 is 6. So then you have the absolute value of 6 is less than 14. What's the absolute value of 6? Well, the absolute value of 6 is 6 because the number 6 is 6 units from 0 on the number line. And then you ask yourself, is 6 less than 14? Yes. So any number you choose between here and here is going to make this work. Okay, so now you see a greater than Greater than means opposite directions. Less than puts you between the negative and the positive. Okay, let's look at, I believe I have two more, just two more. So look at number 3. Another less than. So we've got the absolute value of negative b is less than 7. Okay, nothing on the outside here of the absolute value to get rid of. I certainly have that negative, but that's on the inside, so we'll just let that be. So that means the contents of my absolute value must be less than 7 away from 0. Must be less than 7. So think of your number line. So my contents, I can go to 7, but no further. I can go to negative 7, but no further. I must be less than 7 away from 0, which is going to put me between negative and positive 7. So we drop the contents down, negative b, and we point those symbols always left here. And then I'll do negative 7 here and positive 7 here. Now, the only thing left to do is to get b alone. So now I do want to get rid of this negative. So to get rid of this negative, this is sort of like a negative 1b. So I'm going to have to divide everybody by negative 1. So now I'm going to have negative 7 divided by negative 1 is positive 7. I've got to turn him around because I divided by a negative. Remember that little rule? Here I'm just going to have b, and then I'm going to turn him around, and then 7 divided by negative 1 is negative 7. Now, oftentimes we don't leave compound inequalities in this form. I like to always, this is my final answer, but I want to basically rewrite my final answer so that my b stays in the middle, my smaller number goes on the left, my bigger number goes on the right. And because I did like a 180 here, I'll just flip my signs one last time. And so final answer, b must be between negative 7 and 7. It's less than 7, but greater than negative 7. So how would that work? Well, let's take a look. Let's check it. So find me a number, or think of a number, that is between negative 7 and 7. Maybe like negative 5? Maybe we choose negative 5. So let's float a negative 5 up here. So if we plug in, we have our absolute value. We have this negative that's already there, but then the b we're going to let be negative 5. So let's see if that's less than 7. Okay, the opposite of negative 5 is 5. So I have absolute value of 5 is less than 7. Now the absolute value of 5 is itself 5 because the number 5 is 5 away from 0. And you ask yourself, is 5 less than 7? Yeah. So that's a good check. So I'm thinking we did that right. Okay. And the last one for this video is number 4. I thought we'd take it back to another greater than. In fact, this one I made greater than or equal to. Okay, so now you definitely see I've got some stuff outside of the absolute value here on the left side of the equation. So we need to get rid of this minus 8, and we also need to get rid of the 4. So first, we should add the 8 over. So let's add 8 to both sides, which is going to give us 4 absolute value of x, cross these out, is greater than or equal to 12. Now to get rid of the 4, we're going to divide by 4, divide by 4. So now I have absolute value of x is greater than or equal to 3. And that's looking pretty simplified. Now I'm ready to address the question. The contents of my absolute value, which is nice, it's just an x, the contents here have to be more than 3 away from 0. More than 3 away from 0. Or they could be equal to 3 away from 0. So that the x, the contents have to be 3 or more away from 0. 3 or more, away, greater than 3. None of the numbers in here are more than 3 away. None of the numbers in here. I've got to exceed it on the right and exceed it on the left. So my final answer is that the contents x has to go beneath or equal to -3. Or the contents must go above or equal to +3. Because of the differing directions, you're going to put that or in between. So the differing directions with the greater than has the two statements with the or. The less thans put the contents between the negative and the positive. So you don't have to write a word for this one. So I kind of summarize that in the next sheet here. I just kind of put my quick and easy rules, if you will, that might help you as you're doing your work. So basically, if you have the absolute value with some stuff inside, right? I was calling it the contents. You could also call it the stuff. And you have that greater than a number, right? So you're more than this many away from 0. Then your answer will always look like this. You'll take the contents, the stuff has to be less than the negative number, or the stuff has to be greater than the positive number. So this is the case of when you're more than a certain amount away from 0. You're under the negative or you're up top of the positive. And then the counter to that is if you have less than. The stuff is less than a number. If the distance from 0 has to be under a certain amount, then you're trapped between the negative and the positive. So your stuff comes down, your negative and your positive, left and right, and then your symbols are going to go ahead and point to the left. So hopefully that's going to help you get through some absolute value inequality practice. Thank you for watching and good luck on your work.